Next up is Javier Honduvilla Cotto from Facebook.
Hi, my name is Javier and I work as a production engineer at Facebook London. Today, I'm going to be talking about RBPerf, a new Ruby profiler written in BPF. The first question you might be asking is, why use BPF to write profilers? The main answer is flexibility. The core piece of a profiler is the stack walking code. By writing this code in BPF, it is very easy to build several types of tools. For example, on CPU profilers to understand what are the CPU hotspots of your application, off CPU profilers to know what's causing your program to be descheduled from the CPU, or memory leak detectors, among many other types. The overhead is low thanks to running in kernel space, and the BPF JIT is also very beneficial. We don't have to send signals to the tracee or disturb the Ruby VM's normal execution path in any way. All this allows for continuous profiling in production, which is a super useful thing to have. The usual workflow most developers have when they suspect there is a performance regression is to try reproducing it in their dev environment, or run some profiler in production, hoping that the overhead won't be too high, and that the issue will still be there when they are looking at it. Most of the time, the application needs to be modified and restarted, which makes some investigations harder. A better approach is to continuously profile your application in production. This way, we will be able to catch these type of issues earlier and improve your end user experience as soon as possible. Lastly, RBPerf doesn't require any code modification in the tracee, so your app doesn't need to be restarted or redeployed. Ruby is a dynamic programming language, popular for writing web applications. It has several implementations. RBPerf is able to understand the most widely used flavor, C Ruby. Let's go through some of the examples and see what RBPerf can do for us. It can, for example, help you with performance troubleshooting, thanks to CPU profiling. But it can also trace some events, such as system calls. The interface might be familiar, as it's inspired by perf, the common Linux profiler. Here we can see two commands: record, to generate an on-CPU profile and serialize it to disk, and report, to read a saved profile and generate a flame graph. This is a CPU profile of a Hello World Rails app, a popular web framework. As you can see, these tags are quite deep. We will discuss this in a bit, as it introduces some interesting challenges. The example here is very similar, but we are interested in knowing which Ruby code is calling the right system call. So how does RBPerf work from a high-level perspective? The main component is a BPF code that knows how to walk Ruby stacks in memory. The driver program provides some information that the stack walking code needs and understands the output from said program, which then saves to disk. The way Ruby stack frames are organized in memory is a C Ruby implementation detail. It is not standardized, and we relied on GDB helpers that the Ruby developers kindly provide. Supporting several Ruby versions means that we need to account for small differences between them, such as some structs offset changing, or something that used to be an array that now became a pointer. Something we took early into account is correctness. How do you test a profiler? Fortunately, thanks to trace tracing, we can have simple Ruby programs that, for example, invoke some system calls while we trace for them, so we can verify that the resulting stack trace is the one we expect. Some BPF safety features, such as bounded loops and limited number of instructions, can result in the profiler not being able to fetch the whole stack trace. By using a mix of BPF tail calls, modern kernels, and some messy code, we can traverse more frames. Fortunately, we always know if the stack is complete or not. RBPerf is in experimental status. There is more work to do, but some of the main things I would like to do in the open source version are to rewrite the driver, to allow for a single statically built binary, improve the documentation, open source some of the bits and bobs that were left out, and add support for request-oriented workloads. That's it. Thank you very much. Feel free to ask any questions you might have.
Thank you very much, Javier. Javier will be available in the Slack channel for questions.